Okay, Assalamualaikum warahmatullahi wabarakatuh to Encik Aminuddin and Encik Shahrudin as a panel presenter for me today. So I would like to introduce myself. My name is Muhammad Amirul bin Sazali, student ID B08181072, class of BEA 2/1, and my supervisor is Puan Rozilawati binti Muhammad Noh. So the title of my project is Development of Smart Gardening using Arduino. So let's begin with the introduction of this project. This project is proposed to build an automated garden management system by using Arduino. The idea to develop this prototype was because of the problem faced by human individually who love farming and there is no time to take care of the crop regularly. This method is raised because the plant need careful care to ensure the plant is always healthy. It is a method of monitoring and controlling the basic parameter daily life using a mobile phone application. Then this prototype will assist people in monitoring parameter and ensuring the garden maintenance is on the schedule. Next is the problem statement. For the problem statement, there are few challenges that may occur for those who enjoy and interested in the gardening. They want to take care of their plant in order for them to grow up. However, they are unable to do so in specific situation. For example, some employees must travel to an outstation for a few days or week, preventing them from caring for the plants and flushing them. They also have a hard time keeping track of their plant health when they can monitor and the plant can grow and produce greater. Next, if frequent observation are not possible, most crop will be damaged by insect and fungus attack. After that is the unpredictable weather factor, especially in Malaysia, which is hot and rainy all year. When a when a plant is exposed to the extreme heat and water, it will be die. So we build this project by using the greenhouse as a main casing of this project to counter the problem. So next, project objective. They have a 3 objective. Number 1, to develop an automated garden prototype by using Arduino. Number 2, to design the monitoring garden system by use IoT. And 3, to analyze the performance of the proposed method of the smart garden system. All right. Scope of the project. This project is special for the implement of an automated system for plant and garden in the home area. It uses an 8 mega Arduino microcontroller to run this automatic system. In the creation of this project, it will use several sensors that complement an automated system in this project. The sensor that will be used are soil moisture sensor, humidity sensor, and ultrasonic sensor. Next is about a literature review. So what is the agriculture? In a general, agriculture is defined as the cultivation of exploitation of animal, plant, including a fungi and other form of organic life for human use, including food, fiber, medicine, fuel, and add anything else. It is have been seen there was a horticultural market, one of the largest employer of the people. For example, in the USA today, agriculture represents 20% of the US economy. Okay, next is a type of the gardening. Gardening, which have a process of nurturing and maintaining for plant is included in the landscaping. They have some method of the gardening that be used. One of the most latest technology is hydroponic system technology. Hydroponic is a cultivation of plant without using a soil. Hydroponic flower, herbs, and vegetables are planted in the growing media and supplied with a nutrient-rich solution, oxygen, and water. This system fosters rapidly growth, stronger yield, and superior quality. Hydroponic system work by allowing minute control over the environmental condition like a temperature, pH control, maximize the exposure to the nutrition and the water. Hydroponic operate under a very simple principle, provide plant exactly what they need when they need. They have five types of the hydroponic garden. First is the wick system. Second, water culture system, ebb and flow system, drip system, and FT system. Okay. So we go to the main of this presentation part, which is methodology. First, I will explain about the overall flowchart. First of all, make a brief sketch of the shape we want to make and what is take to make the project work as we outline, such as selecting electronic and electrical components such as sensor and other hardware. For example, temperature sensor and a water pump. After the selection of the component, the full sketch include with the component that have been selected is made and to ensure whether it fit what we want and can operate as a desired. If the sketch can be adopted, it can create a program. It uses C++ programming language. The arrangement in the program must fit as we wish. If the program is operating well, we can start with assembly of the electrical and electronic hardware item following the full sketch we have made. If the process runs smoothly, it can be turned into the final product and analyze a full report. So next for the mechanical design. So at the design, we can see the using of the greenhouse as a main casing in this project. They have two levels. At the bottom, we will place the control panel, motor pump, and the water tank. At the upper side, they will use the solar panel as a power supply, the exhaust fan to absorb out the heat, and the air vent to controlling the humidity that controlled by the DHT 12 sensor, the soil moisture sensor, and the water nozzle. And this dimension of the design, they have not too small and not too big and suitable for the home area. Okay, so for the soil moisture sensor flowchart, the flowchart focus on the process in the type of sensor called a soil moisture sensor. This sensor is intended to determine the soil moisture, whether it is a dry or moist. The sensor is connected to the water pump, where if the soil humidity is less, the water pump will run the pump to water the storage tank and continue to flow through the pipe and go to the nozzle. The function of the nozzle is to distribute water evenly over the plant. Next is a temperature sensor flowchart. This flowchart focus on the process in the type of sensor called a temperature sensor. The sensor work to measure a rate of temperature found in an area as it project measure temperature in the greenhouse. This temperature sensor is connected to the exhaust fan. The function of the exhaust fan is to suck out the hot heat present in the greenhouse up to the ideal temperature level. If the temperature sensor find that the temperature exceeds the predetermined limit, the sensor will send a signal to the microcontroller to activate the exhaust and inhale the hot air present in the greenhouse. The fan will continue to operate until the sensor get a low reading. If the temperature sensor get a standard lesson, the exhaust fan will stop running. Next, for the humidity sensor flowchart, this flowchart focus on the processing of the type of sensor called a humidity sensor. This sensor work to measure the rate of humidity present in an area. As in this project, it's measure the humidity inside the greenhouse. If the humidity sensor find a very low humidity above the predetermined, the sensor will send a signal to the microcontroller to activate the DC motor and let air from the outside in and stabilize the humidity inside the greenhouse. The DC motor will remain in the forwarding condition until the sensor get a high reading. If the temperature sensor get a high lesson, the DC motor will return to reverse state and close the vent. The smartphone will display the data read by the humidity sensor via Wi-Fi. Okay, so next is a hardware requirement. Okay, the first one is we use Arduino Uno as a main controller in this project because the price is cheaper and the use of the language C++, and I familiar with the language. So I choose this. Other side, there is other controller just like a new Raspberry Pi, but the main reason is I doesn't choose the other controller because the programming language, and the price of the controller. Next is the soil moisture sensor. Soil moisture sensor is function as a device that leveling the humidity of the soil. The fork-shaped probe which has two exposed conductor function as a variable resistor similar as a potentiometer, whose resistance varies with the amount of water in the soil that connected to the water pump to watering the garden. Next is a temperature and humidity sensor, DHT12. The DHT12 is a primary digital temperature and humidity sensor at a low price. It measures a surrounding air with a capacitive humidity sensor and thermistor and output a digital signal on the data pin. And no analog input pin is needed. This sensor is connected to exhaust fan to suck out the heat and DC motor to controlling the humidity. DC motor execute of this project for controlling the open and close of the air vent in this project. They need ample torque. When we using this DC motor because they need an ample torque and controlling the speed of the motor to ensure that the air vent can open and close smoothly. After that is ultrasonic sensor. Ultrasonic sensor are most commonly used in this project. Level of water in water tank. The device that use sound wave to calculate the distance between a target and the barrier and has many frequency per second. Next is ESP8266. The ESP8266 is a low-cost Wi-Fi module for the ESP family that may be used to control electronic project from anywhere on the planet. Unless they have a Wi-Fi, module can communicate with the Wi-Fi signal using the TCP/IP protocol stack. Because the module maximum working voltage is 3.3 volt. If you can't use the 5 volt, you can use the 5 volt because it will damage the module. The ESP8260 is linked to the local Wi-Fi hotspot, allowing it to connect to the internet and provide data and verification number to the Blink server. So next is solar panel. Solar panel is function is to collect and convert the sun energy into the practical electricity to supply 12 volt to the Arduino frequently and can sustain till 5 days without a sun. After that, it will connected. This is a solar panel connector. They have a charger controller, battery, and a solar power inverter. Charger controller, as known as a charger regulator, is regulate a voltage and current going to the battery from the solar panel. Then for solar panel inverter, the variable DC output of photovoltaic solar panel is converted into the utility frequency and alternating current AC that can be supplied into the commercial electrical grid. So next, we will go to software requirement. We use the interface of a software Arduino IDE. Multiple tools are available to model and execute in this project. The software is Arduino IDE. Arduino is an open source. There is a main point why I choose it. A framework for the developing a project that include electronic component that must be programmed and run to complete the project. Next. Next is Blink server. The function is to responsive to the communication between the smartphone and the hardware. You can use our Blink cloud to run your private Blink server locally. It's an open source, could easily handle thousands of devices. Okay, next for the initial result or primary result. For the initial result, for now, I ready to try the simulate on the Proteus software to run the soil moisture sensor with the DC motor to controlling the speed. But for now, it doesn't have a positive result yet. They have a problem with the program. This is a wiring circuit, and this is the coding, the program. Okay. For the conclusion, this project named as a development of the smart gardening system by using Arduino have been done for the rafting design of the electronic hardware and software we developed in this intelligent garden. In PSM2 of this, the primary function of using automatic mode is to ensure that the feature requirement in this system can be monitored and smartphone application. The data collected is the humidity of the greenhouse, the current temperature of the greenhouse, and the humidity of the soil. All that system is connected to the motor and the humidity soil. All the system is connected. All the system is connected to the motor controlling data following the program that already set up. The system is used IoT as a connected to link a greenhouse with the smartphone. IoT refer to a network item or identities that can communicate with another through the internet. Okay, this is a Gantt chart for PSM1. I already finished from the week 1 until the week 15. Week 1, we start with briefing the workshop PSM1 until the presentation PSM1 right now. After that, we will go through the Q&A session. So thank you for hearing the presentation. The credit is given to the Puan Rozilawati binti Muhammad. Thank you so much.